Welcome. Today I'm thinking of programming an insertion sort, which will be a prelude to a future session on the great Tim Peters sort. So join me and let us quickly set up our test environment. And this is going to take just a few seconds. Should respect our specification. So write a method in the sort. Let us write a failing test first. Once I have a test suite configured properly, we can use this to evolve the design. Cool. Our test configuration is ready and we can start our game now. Insertion sort is all about placing an element at the right place. The right place is a aspect that I am planning to discover through this test. So I have created an entity. Let us start with a simple step. So if our entity is 4, 1, if it is order, it is a U32. And it should be sorted like 1, 4. Simple. And let us do the sorting from the reverse. So let us keep our pointer at the last element, that is the J. And if current is now pointing to the last element and the previous is J minus 1. If previous is greater than the current, then the call for a swap. Otherwise, we don't want to do anything. Simple test. Fine. And then naturally, and let us increase our test span. Seem to introduce one more element now. And then we know that this is going to fail. Let us see the result of the operation. So it just transformed the last but one element. That is 4, 1 is becoming 1, 4, and the position of 3 is not yet touched. So let us do a simple, let's do that from the reverse. Let us go until the end of, so the J is the inner loop. We know that this is a very poor way of doing a sorting, but let us do what is bare minimum to make the test to pass. So the performance will be n into n minus 1 by 2 times it will go through the loop and it will sap. Anyway, now this is a one more test. So should place element at position. Let's call just this. Let us create one more test now. So it is more like sorting the term the reverse. Now let us get into one more sort that is more of placing an element at the right position. So the test will be, let us make some assumption now. Let us assume that we have a pre-sorted list except for the first element. That is, we call this a head element in the insertion sort. Let us assume we have 4 followed by 1, 3, 5. That is 1, 3, 5 is on the natural order. And now we have to find where to place this 4. So this is a central concept of insertion sort. And this will be used extensively in the stem sort as well. So finding the right place for the head and where to drop this head, that is what the idea of an insertion sort. So this, the assumption is the first element is lesser than the, 0th element is, what is the first element I mean? Use destination instead of index, and let's start it from the second element, because we already have the difference that if the first element is greater than the 0th, then we are returning. So we already moved the first element, that is slice 0 to head, and then we'll start our journey from the second. Slice of index, and this is index minus 1, and we need a condition to break, and if slice of I is greater than equal. That's it. And let us drop the head at the destination. So we assume that we are using a U32 now. So that make us to arrive at the algorithm very easy because it is a copy type. We'll discuss shortly what is a copy type. And this should pass. Let's now use this algorithm of should place element for the insertion set. Just to show you how the individual elements are moved. That is, first it is 4135. Let's put one more println to show you how after we have moved the 4 will be in memory, and 4135 will become 1135, and it will become 1335. Now the destination reached the second index, and that is a place where we are going to drop the 4. So it will become 1345. So that's the idea. So let us leverage this place set position for our insertion set. So the assumption is the first element, that's the 0th element, is something that we have to place at the pre-sorted list. So this is an advantage of working from in a loop in a reverse order. Let's call the place in position from within this loop. Let's pass the slice starting from the ith position until the end. Mu. Okay. Let's make this as from 0 to n minus 1. They didn't consider the first element at all. So now we have reduced the iterations of a for loop to get a degree. Let's check whether this is working for some bigger numbers. During the dubbing, I find that I cannot change the poor sort there. I'll change it shortly. Please be patient. I made the test to fail so that the println prints. Otherwise, a test won't print the println intelligently. It will skip any println. So I deliberately made the test to fail. The reason it is not printing 1, 3, 10 is that I have called the poor sort there. I have not yet called the insertion sort. Okay. So let us put that in a main to print how the slice is getting progressively sorted. Yeah, yeah. It's a problem of copy paste. Let's run the test again to prove to the audience that this is working fine, and then we'll call this to check how the elements of the array are sorted progressively from the reverse order. So this 1 and 2. So in the next session, we'll make this a little bit generic. Thank you.